In our last example, this is our last example on geometrical ratio, aspect of similarity. So we have the scale of a map is given. When a map scale is given as linear. What I mean is that this implies that if 1 centimeter on paper may represent 500,000 centimeter in reality. For example, maybe the length of a town, or let me say the length of a particular maybe road is 500,000 centimeter in reality. That is on land. But if you want to represent it on paper, you use 1 centimeter to represent it. That means this aspect of ratio is trying to tell us that the one you have, just like if you have your portrait, your photograph, the image you have there and your physical image, the real one, both of them are similar. Both of them are similar, but that doesn't mean they are of equal size. So that's what we are taking here. In the first one, in A part, this A part, we are giving that the actual, in every occasion, you first write the ratio of the scale. We know that 1 over 500,000 equals to, it's just the ratio on paper to that of the land, to that of the reality, equals to, is there any other paper to reality? Let's read. The actual distance between two towns is 172 kilometers. That's actual. We have it as denominator. 172 kilometers. Calculate the distance in centimeter between the two towns on map. The one map is on top. So the distance is what we have to find. But the thing is that since this one is ratio, the unit is already removed. So you can use it for anything. But the unit of this D now is determined by this 172. Since this 172 is kilometer, the answer you get for D when you solve will be in kilometer. If they ask you to leave it in centimeter, it is that answer you now convert to centimeter. So let's see how it goes. So we cross multiply. We have 1 times 172 equals to 500,000 times D. So you now have 500,000 D equals to 172. And for you to make D the subject, you divide both sides by coefficient of D, which is 500,000, meaning that D becomes 172 divided by 500,000. So if you simplify this, first of all, if you say 172 divided by 500,000, that should give us D equals to 0.000344 in kilometer. But since we have to leave our distance between the two towns in centimeter, so you now say how many centimeter can you find in 1 kilometer? It is, since it is 100 centimeter that we have in 1 meter, and it is 1,000 meters that we have in 1 kilometer, that means we have 100,000 centimeter in 1 kilometer. We multiply this answer by 100,000. So we have this equals to 0.000344 times 100,000. So D will simply be, multiply your answer by 100,000 times 100,000. That should give us 34.4 centimeters. And that's the distance between the two towns. This distance, that is the distance that will represent 172 kilometers in reality. on paper, it will be 34.4 centimeter. In the B part, we have to find the area, the B part. Okay, the area of a lake on the map is 12 centimeters square. We are given the one on map, and we have to calculate the actual area in kilometers square, in square kilometer. So what we are doing is that you always start with your scale. You say the ratio on paper to that of land, 1:500,000 equals to, but this time is the one of map we are given, that is 12 centimeter over the area in, but I told us something that anytime you are equating ratio of area to ratio of size, this one is linear. Map scale is always linear. So you put, to conform them, put square both of them. And this will mean this 500,000 will multiply 500,000. That means you will have here, you have 1 times 1, that's 1 square, over 500,000 multiplying another 500,000 to get 12 over A. So from here, we cross multiply. This A will multiply 1 there, that is 1A, which is A, equals to 500,000 times 500,000. Let's do it this way. 500,000 times 500,000 first. 5 times 5 is 25. So times this 0, we have 1, 2, 3, 4, 5 here. We have 1, 2, 3, 4, 5 here. That is 10 to the power of 10. Because 50 already means 10 to the power of 5. So 10 0 will mean 10 to the power of 10. So we now use it to multiply 12. That's the value of A. But this A now is in centimeter square, because the value we used there in the first place, we substituted for neutral ratio, is centimeter, is in centimeter. So this one too, this area will be in centimeter square. Now, but we have to leave our area in kilometer square. The thing is that since it is 100,000 centimeter, that is equals to 1 kilometer. Then 1 kilometer square will now mean 1 kilometer square means 1 times 1. 1 kilometer times 1 kilometer will give us 1 kilometer square. 1 kilometer times 1 kilometer, 1 kilometer times another 1 kilometer will give us 1 kilometer square, which will mean if 1 kilometer is this, it will mean this one will multiply itself too. That is 100,000. 100,000 centimeter will multiply by another 100,000 centimeter. So that is, it will be multiple of 10 that has how many zeros? That has 10 zeros. That is 10 to the power of 10 centimeter square, which is same thing as 10 billion. So since we are converting this to kilometer, we divide this one by 10. That's 10 to the power of 10 centimeter square. So our area therefore becomes A equals to 25 times 10 to the power of 10, 10 times 12 divided by 10 to the power of 10. So from here, this will cancel, and we have the required area being 25 times 12. And if you do 25 times 12, we'll get 300. So we have successfully converted to kilometer So that means an area 300 kilometers square on land is represented by 12 centimeters square on paper. This is the final answer of the B parts. So to test our knowledge of these concepts, having gone through example 1 to 5, we'll quickly check this class exercise. So let's try this class exercise out.